let's say if I replace bank with some other entity,
which is ocean wave in this case.
yeah, or
physical system.
yeah. Two things can happen. Either I can become corrupt, or the other entity which I'm replacing with bank, that can become corrupt. So they can take money from me, or I can, in case of electronic system, I can double spend it. So I can send the same amount to you and to somebody else. In case of electronic system, in case of gold, sure, double spending, you can't do that.
Yeah.
So okay, what does the bank do? It has all the records. So let's say when I started my bank account, I deposited $10,000. So from then on, all whatever transactions I did, bank knows everything. So bank has the entire history, and then it sees that, oh, finally, right now I have $2,000 from which I am sending $50 to somebody. So to arrive at that conclusion, you need to look at the entire history, and only bank has it. But if I take out that history, they call it ledger, which has all the transaction history. So if I take this ledger out and give it to everyone, so imagine everyone means everyone. So everyone has my record. That okay, I started from $10,000. Right now I have arrived at $2,000. So from then on, what I decide to do, I will need to tell everyone what I'm doing. So if I'm sending you $50, I will tell everyone, okay, everyone, I have $2,000 as you can see because all of you have my data, and then I'm sending it $50 to you. Then everyone listens to this, and then they update their ledger. And now I have what 1950. So this is the value of this is the key essence of decentralized system. So if everyone knows my history, then it is highly difficult for anyone to become corrupt. So I cannot become corrupt. I can't say I'm sending you $3,000 because nobody will accept this transaction because everyone knows that I only have $2,000. So that's the key essence of having a decentralized system, which is a good replacement of the bank because right now I have that full history just like the bank has, but I am not putting all of my trust into one single entity. So I'm assuming like at least 51% of them, as long as 51% of everyone is honest, then the system will not be corrupted.
Is it a coincidence that the problem of double spending, which is resolved by everyone having a ledger and awareness of how much money the sender has, is it a coincidence?
It is not solved just by this system, by the way. So when I'm making the transaction, it's not immediately finalized, right? So I start this transaction, then I broadcast this to everyone. And by everyone I mean like computers here. So some computers listen to this transaction. Some may listen after a few seconds because they're located very far or whatever. So and then immediately after that I decide to spend more money. So there are like many transactions happening in any second, and all these computers are receiving different transactions in different order maybe. They won't necessarily receive the exact same order. So, and as I said, everyone has this ledger which gets updated. So who actually gets to update this? That is a problem. It's not a that is not a that
straightforward. Yeah.
There used to be no straightforward solution to this before. Because who actually gets to write it? Because one may say that, oh, I got transaction 1 first, then transaction 2. The other person will say, no, I got transaction 3 first, then 2, then 1. Who actually gets to update it? So that's where Satoshi Nakamoto in 2008 he came up with a good solution to this problem.
And
the solution is basically okay. This overall problem is called consensus problem. So all these computers need to have consensus regarding what to write in what order. So this consensus mechanism is what Nakamoto came up with. So the key essence is that the computer who gets to write, so we have a measure of the skin in the game. So the skin in the game is in the case of Bitcoin is basically about computing power.
Wait, sorry, what is this? I have heard this with a forward.
Skin in the game.
What does it mean?
Oh, like how much actually you are involved in the game. So
Okay.
I'll give you the details of that. So,
So
all these computers have computing power. So let's say, yeah. So let's say I am sitting here and I send out this transaction and I'm broadcasting this to the network. So these are we call it nodes, which are basically machines. So Bitcoin nodes. Okay, yeah. So what happens is that any particular node 1, node 2, node 3, they all receive various transactions. And then what they do is that they sort of compete to get to write the next bunch of transactions. So, yeah, I'm not sure if it is the best way to arrive at blockchain as a concept, but we basically write the information of the transactions in the form of blocks. So in one block, we have the transaction information. So there might be many transactions. And what we have is information about the previous block. So one obvious question may arise is, what is the first block? Because that's the starting point. So the first block was created by Satoshi Nakamoto when he first wrote the Bitcoin's program. From then on, what information did it have? So there was no transaction because nobody had any Bitcoin at that time. So he put some random messages here just to have a first block. And then there is a concept in computer science which is called hashing.
Yeah.
So hashing is hashing. So you can take hash of any data. So it can be string, number, whatever. So you put anything here, and depending on what hashing function you use, you'll always get a certain amount of ones and zeros. And this, in this case, it is 256 bits. And it is a cryptographic hashing function, which means you can't take inverse of that to reach at this that easily.
So is the function a mathematical function or a program?
I mean, so you implement using programs, right?
Program. Yeah. It's not. There's no formula for it. Otherwise, you can always take reverse. Okay.
That's the thing. I mean, I don't know all the details about this, but apparently it has been very difficult to reverse engineer. So this is used to sign the transactions. So these two problems which I mentioned before, that verification and double signing. So I'm talking about verification. So when I'm sending this transaction, I sort of sign it. And to sign it, what I need is, so when I create a wallet or my account in Bitcoin, I have something called public key and something called private key, which here I'm calling secured key. So public key, anyone can see my public key, that's fine. And these two are sort of related. So the secured key, that is only my information. I should only know that. It's kind of like a password, but used in a different way.
And is it related to hash function?
Yeah, it is related to verification. I will come to that. So when I create my account, I have these two information, and this secret key I keep to myself. And then when I make a transaction, the transaction will have some message. So that message may include send Saksham 10 Bitcoins.
Yeah.
So I have a message and I have my secured key. If I take a particular hash of that, then that becomes my signature.
Yeah.
So the important bit here is that it's easy to verify that I am the one who created it, but it's difficult to know what is inside that. So
Yeah.
there is a verification function where you can take the signature and the public key, because public key anyone can know. That is fine. It is supposed to be public. Then this can become a true or false function.
Is it true or false?
Yeah. So I'm sending this transaction. Anyone can verify that I am the one who is sending it.
So is the verification function and hash function
Yeah.
Related to each other somehow, or
they are related through this public-private key pair. So,
yeah, but you can't go from hash function to verification function, or vice versa.
You can't. The important bit is you can't reverse engineer this.
Yeah.
So at best, when you are getting a signature, you can only check if a particular person signed it or not. But you cannot reverse engineer to find his secret key.
Yeah.
Because that will involve guessing a 256-bit long byte, and that is very difficult guessing work. You will have to basically keep on. There are how many? 2 to the power 256, and this is a ridiculously big number.
It's like more than 10 to the power 100, if I heard correctly. Yeah, it's equal or more than number of atoms in the.
Oh yeah. It's beyond astronomical. So there is no way one can simply guess it. So that's why this system is used to verify, because this is fairly secure.
And you also mentioned this notion of computational power.
Yeah, that's what I'm coming to the next step. So the verification part is now clear. I use this public-private key system to send out my transaction so that they can be verified. The second thing is double spending problem. I'll come to that naturally. So I have sent my transactions, and these nodes have gotten it. Then the next step is to actually write those transactions in the next block, because what does this public ledger in Bitcoin look like? It is a chain of blocks. That's why it's called blockchain. So it looks like, there is one block here, there is one more block here, and it is like a chain basically. And the first one was created in 2008 or 9 by Satoshi Nakamoto, and from then on, these have been built on top of that. So once these transactions have been broadcasted, these nodes sort of compete against each other to solve a problem. I can go to the details of that problem, but to solve the problem, and whoever solves the problem first gets to write the next block. And what will he write in that block? The transactions which he received. So those transactions he will receive, those he will write, and he will also put information about the previous block here. This thing will be part of this block, so that they are actually connected.
Are they connected only in a forward and one backward fashion, or is it like slightly?
No. It's like
linear.
Yeah, it is linear. So there can be divergences that I can mention that right now. So okay, let's say the node with the highest amount of computing power, or most likely a high amount of computing power, he gets to solve that complex puzzle, so that he gets to write it. It may happen sometimes that somebody else has also created one more block, and so there might be like a tie. We need tie breaks, and the tie break happens is that whenever you get new blocks, if there is another node here, he first knew, okay, this is the blockchain. Then he got this thing as as the broadcasted blockchain. Then he got this entire thing. Then he got one more here. So then, how to decide tiebreak is you just take the longest one. So the longest chain wins. So if you have multi-chain at one point, you just pick the longer one. If you don't have one single winner, then you just wait for a bit more until you get one chain longer than the previous one.
Long in what sense?
Long means
because if the two people are competing, two blocks are competing, I mean, if you go anywhere around, balance would be same. So what's the notion of that?
So this can happen in multiple ways. So one is, let's say if I'm trying to corrupt the system, then the only way I can do it is that if I come first in that competition. What that means is that I will create my block here, and let's say I'm corrupting because I have sent I have sent some transactions which I don't have authority to do. For example, they are double spending or in whatever way. So, okay, I managed to create it before anyone else did. But what happens next? So it is easy to verify that this is not correct. So most likely people will not accept it. But during that time, I can create one more so that to become the longest node. But to be able to make back-to-back blocks, it's a lot of work. It's unless you control more than 51% of the entire network, which is like you have to have computing power worth billions, if not trillions. If you can't do that, then easily others will recognize that this is a fraudulent one, and they will discard it, and then they will take the correct one to update it. So this is the way double in this manner this double spending problem is solved. So this is basically the overall idea is to reach consensus mechanism in a distributed system. So this is called Nakamoto consensus. So okay, one problem here. I will come back to this computing thing now. That competition which they do. So that's very interesting actually. So it's basically what they try to do is.
Maybe
Sorry? Yeah, I think it is visible here. Let's say. So let's say, so when you create a new block, the information which you have is the previous block hash and the new transactions. And when you combine all these info and you take the hash of that entire thing, you will reach at let's say some hash like that, let's say. And I will add a random number to it. It's called norms, but the name is not important. That number can, I'll start with 0, increase it to 1, then 2, then 3. Each of those times, my aim is to have to arrive at this norms in a certain way, a particular number, so that the overall hash starts with certain number of zeros. So let's say 3 zeros followed by whatever, and it's 256 bits. So I can't simply randomly guess this number. I'll have to like brute force it. I'll do it, check for 0, take its hash. Okay, it doesn't match. So take 1, then do, and maybe after like few million iterations, I will arrive at a nonce number so that the hash of this entire thing starts with 3 zeros. So as you can see, this is basically brute force guesswork, which needs computing power. Which is why, yeah, you need a lot of computing power if you want to have your own node in Bitcoin network. So that's where the computation comes, and you might have heard that it's not good for the environment because you need a lot of computations, which there are other alternatives to solve this problem. This was the first one which was suggested by Satoshi, and that basically kickstarted everything, but there have been other ways to arrive at consensus in a distributed system, which solves this verification and overspending problem as well. So those would be the next solutions, which we can talk on some other time. But this is the sort of the details of what computation happens. But you may ask why these nodes are doing this, why they are spending so much money and resources to do all these computations, because they get some reward. Okay. So they can get reward in two different ways.
externally or?
It's all coded. The node which creates the next block, they by default get some Bitcoin, which is actually generated, which did not exist before. So, as I said before, the inflation part of Bitcoin. So, theoretical maximum limit of Bitcoin is 21 million. And right now, I don't know the exact number, it's probably 18 or 19 million. So, what happens is that when a new block is created, certain number of Bitcoins also get created, and they will go to the node which created it. So that's how they earn it, earn something after spending so much resources. But then you may think, okay, how is the number constant then? And that is the way they do it is after every certain number of blocks, they have the amount of reward that is available. So right now it's, I don't know, 6 or 10 Bitcoins per block, something like that. When the first one was created, it was probably 100 or some number like that. But that number of Bitcoins that gets generated for every new block, that keeps on decreasing with time. So that 21 million is the asymptotic upper limit. And that will probably reach like after many years. Even after that, that is one more way of getting the nodes to incentivize, and that is when I send a transaction, there's a fee. So I send a little bit of fee with that as well. So that if I'm sending you 10 Bitcoins, I'll probably totally spend 10.5 Bitcoins maybe, where the 0.5 Bitcoin will go to the node who actually creates the block. Yeah, so these are the two ways the nodes get incentivized. Yeah, that's it really. So this way we solve the problem of inflation by having constant supply, total possible supply, and it is highly decentralized, as you see. No unlimited supply, and yeah, it is electronic, and you solve this verification and double spending problem. And this is how Bitcoin started. And there are some challenges, of course, as you can see the extra usage of power, which there are alternatives now. But in theory, it can scale really well. But because of this wastage of power, that's why we want other alternatives of Bitcoin. So there are, when it started, it was initially conceptualized to be an electronic peer-to-peer cash system. But slowly it has shifted towards becoming more like a digital gold. So I don't hold gold just so that I spend it every day, right? I hold gold mainly as a store of value, just like real estate in a way. Similarly, Bitcoin has been shifting towards that way, but it can still be in theory used as a proper cash system. Like recently, El Salvador, I think they made Bitcoin the very center, so people there are using Bitcoins now. And yeah, this is one of the ways Bitcoin can be helpful, or the concept of Bitcoin can be helpful, is that there are some countries where their legal tender is US dollar. They don't have their own separate currency. But if they shift to systems like this, like Bitcoin or some other cryptocurrency, then they can become more decoupled from centralized systems like US dollars. And with all these advantages which Bitcoin brings. Yeah, so that covers the current challenges of Bitcoin. So there are many other cryptocurrencies, like the second most popular one is Ethereum. Yeah, that's basically not just a cash system, but you can actually build applications on top of that. But yeah, that's for some other time.
Sure.
Yeah. But yeah, I guess it's probably what 40 minutes already. So yeah, I guess that's a good time to stop. So, thanks.